I wrote CMOS circuit design, layout, and simulation because I wanted a textbook that would cover both analog and digital circuit design along with layout and simulation. I wanted the whole process. And in addition, I wanted to have some supporting material online because the internet was coming, being very popular and growing back in the late to mid 90s. And so I wanted to have tutorials on simulation, on layout, on circuit design, worked problems, now videos. And so I have a site that goes along with the book, CMOS edu, CMOSedu.com. On the website there are videos, worked solutions to problems in the book. There are additional homework problems. There's information on using layout software for the PC. There's information on using layout software that Sun sponsors that works in both the Unix and Macs and the PC. There's additional information. Not only is there information on CMOS circuit design, layout, and simulation, but there's also information on DRAM circuit design, fundamental and high-speed topics, and on CMOS mixed signal circuit design. The videos at CMOSedu.com. There are 4 classes that I taught at Boise State. The videos are there for the lectures. So that's roughly 160 lectures in all areas: analog, mixed signal, digital, memory, circuit design. Those anybody can view. You don't get credit, but you can view the lectures if you want to brush up on some topic. There are also videos on using software. I found that when I teach my classes that I was spending a great deal of time covering software and how to do a layout of an inverter or simulate the operation of an inverter. And I didn't feel that was time well spent in the lecture, during the lecture. And so what I did was I spent time and put all these mini 20-minute, 25-minute lectures online so that someone that wanted to know, hey, how do I operate SPICE, or how do I know the fundamentals, how do I do a DC sweep of a resistive divider, could go and in very few minutes watch a video and some examples and learn how to do it. That way it freed up time in the lecture as well. All the information on the website is free that supports the books and supports circuit design education, the videos, the layout software, the SPICE simulation software, all that's available for anyone to download and look at for free. We want to provide a set of books that has a companion website and companion material to support learning activities. In the future, what's going to happen, Moore's law is going to run out. The transistor, what that means is the transistors won't match as well. One transistor won't behave exactly the same as another transistor, so the design techniques are changing. So traditional analog techniques or traditional digital techniques will morph into this mixed signal technique, which relies on signal processing, high-pass filtering, low-pass filtering, delta, sigma modulation, all these techniques that are tolerant to poor transistor behavior. I was very honored to win the Terman Award this year. It was especially an honor because it was, I had 3 attempts to get it. It's for writing a textbook, which I feel very proud, and I've put a lot of effort into authoring the online website. All this information to get the recognition is just outstanding. I feel that the Terman Award, if you look at the list of recipients, is really an indication of quality work, and to get the recognition for the books and the Terman Award by itself is just, an honor beyond words. When I wrote CMOS circuit design, layout, and simulation, I wanted a textbook that had a very strong industrial slant. I think that academics have a tendency not to associate themselves with industry, and I felt that that can be a double-edged sword. On the good part, you can focus on your research. On the bad part, you lose track of where your students are going and what they need to know when they go there. And I have worked with industry for 20+ years, and I constantly do consulting on things as diverse as CMOS image sensors to flash memory design. And the books were written with the idea that if the person that studies the book were to go out and get a job in industry, that they would be well prepared to tackle modern problems that are facing engineers that are designing these products. If you're in industry right now, my feeling unbiased of course, is that you won't find a better book than CMOS Circuit Design, Layout, and Simulation to be your companion while you're designing or you need to learn. The website as well, quick reviews of a large list of topics available right at your fingertips, provided you have internet access. So the level of background someone would need to study CMOS circuit design, layout, and simulation is a knowledge of digital logic design like Boolean algebra, ANDs, OR gates, Carnot maps, a course in linear circuits, RC circuits, RLC circuits, Bode plots, AC, basically sophomore level electrical engineering, and then an introductory class in microelectronics where they've seen diodes and rectifiers and transistors for the first time.